Welcome to Astronomy Daily. Today, we're diving into an incredible lineup of space news that showcases both the fascinating and sometimes humorous side of space exploration. From a case of mistaken identity involving Elon Musk's orbiting Tesla Roadster to groundbreaking lunar gravity experiments, we've got an action-packed episode ahead. We'll explore new concerns about astronaut health in space, take a look at the latest observations of the famous M87 black hole, and preview some spectacular celestial alignments coming up in our night sky. We'll also discuss NASA's innovative approaches to dealing with that pesky moondust problem that's been challenging lunar missions since the Apollo era. So get ready for your daily dose of space and astronomy news as we explore these exciting developments that are shaping our understanding of the cosmos. In a delightful twist of astronomical proportions, Elon Musk's Tesla Roadster, launched into space 6 years ago, recently caused quite a stir in the scientific community. Earlier this month, astronomers at the prestigious Harvard-Smithsonian Center for Astrophysics Minor Planet Center mistook the wandering vehicle for a newly discovered asteroid, even giving it an official designation, 2018 CN41. The cosmic mix-up didn't last long, though. Just a day after registering the supposed new asteroid, the center had to quickly backtrack when it became clear that their mysterious object was actually Musk's space-traveling Tesla, which had been cruising through space since its launch aboard SpaceX's Falcon Heavy rocket in February 2018. What makes this particularly interesting is that the Roadster was spotted less than 150,000 miles from Earth. That's closer than the Moon's orbit. Originally intended to travel in an elliptical orbit around the Sun, extending just past Mars, the car apparently exceeded expectations and ventured further into the asteroid belt. This case of mistaken identity highlights a serious challenge in space observation. As noted by Center for Astrophysics astrophysicist Jonathan McDowell, tracking objects in space isn't always straightforward. In fact, he pointed out that in a worst-case scenario, you could spend $1 billion launching a space probe to study what you think is an asteroid, only to discover upon arrival that it's something entirely different. The incident serves as a reminder of both the complexity of tracking objects in space and the increasing number of human-made objects joining the natural celestial bodies in our solar system. Who would have thought that one day we'd need to double-check whether that new asteroid is actually just a luxury electric car taking a very, very long road trip? Next up today. Blue Origin is gearing up for an exciting milestone in space research with their upcoming new Shepard flight, scheduled for January 28th. What makes this mission particularly special is its innovative approach to simulating lunar gravity, something that could revolutionize how we prepare for future moon missions. Unlike previous New Shepard flights that achieved microgravity, this mission will deliberately spin the crew capsule after it separates from its booster. Using reaction control thrusters, the capsule will rotate at approximately 11 revolutions per minute, creating conditions that perfectly match the moon's gravity for the payloads inside. This unique capability will provide researchers with an unprecedented 2 minutes of lunar gravity conditions. To put that in perspective, current testing methods using parabolic aircraft flights can only manage about 20 seconds of simulated lunar gravity. The extended duration opens up exciting new possibilities for testing lunar technologies and conducting research. The mission will carry 30 different payloads, with 17 of them coming directly from NASA through their Flight Opportunities program. These experiments span crucial areas for lunar exploration, including resource utilization, dust mitigation, advanced habitation systems, and various spacecraft technologies. One payload will even be mounted on the exterior of the new Shepard booster to test how materials react to the space environment. What's particularly promising about this development is its potential for future applications. Blue Origin's CEO Dave Limp has indicated that this technology could be adapted to simulate gravity conditions for Mars and other celestial bodies in our solar system. This versatility could make it an invaluable tool for preparing for human exploration throughout the solar system. For NASA and other lunar technology providers, this new testing platform represents a game-changing opportunity to accelerate their research and improve technology readiness at a fraction of the cost of traditional testing methods. It's a significant step forward in our journey back to the moon and beyond. While on the subject of the moon, NASA has just launched an ambitious new mission to tackle one of the most persistent challenges of lunar exploration, moon dust. The Blue Ghost Mission 1 recently lifted off from Kennedy Space Center, carrying two groundbreaking technologies designed to help us better understand and manage lunar regolith. One of these innovative devices is the Electrodynamic Dust Shield, or EDS, which uses electric fields to lift, transport, and remove dust particles from surfaces. This technology could be a game changer for future lunar missions, as moon dust has been a significant headache since the Apollo era, causing problems with everything from spacesuits to essential equipment. The mission's second key technology is equally fascinating: the stereo camera for lunar plume surface studies, or SCALPS-S. This system will capture high-resolution stereo images of how rocket plumes interact with the lunar surface during landing. As we plan to land increasingly larger payloads on the moon, understanding how these powerful engines affect the surface becomes crucial. These experiments will be conducted in Mare Crisium, a massive dark basin on the moon's near side spanning about 300 miles. This location will provide the perfect testing ground for these technologies in actual lunar conditions, something that's incredibly difficult to replicate accurately on Earth. The timing of this mission couldn't be more crucial. As we prepare for more complex lunar operations, managing moon dust becomes increasingly important. During the Apollo missions, astronauts discovered firsthand how problematic this fine, abrasive material could be, coating everything it touched and potentially damaging sensitive equipment. What's particularly exciting is how this research will benefit future Mars missions as well. While Martian dust has different properties than lunar regolith, the lessons we learn from these experiments will be invaluable for designing dust mitigation systems for both worlds. It's another excellent example of how lunar exploration serves as a crucial testing ground for our eventual journey to the Red Planet. A new study published in the IEE Open Journal of Engineering in Medicine and Biology has revealed some concerning findings about how space affects astronauts' vision. The research shows that after just 6 to 12 months aboard the International Space Station, astronauts experience significant changes to their eyes and vision due to the microgravity environment. The findings are particularly striking. At least 70% of ISS astronauts have been affected by what's known as spaceflight-associated neuro-ocular syndrome, or SANS. Researchers analyzed data from 13 astronauts who spent between 157 and 186 days in space, and the changes they documented were substantial. They found a 33% decrease in ocular rigidity, an 11% drop in intraocular pressure, and a 25% reduction in ocular pulse amplitude. These changes aren't just numbers on a page. They manifest in real symptoms like reduced eye size, altered focal fields, and in some cases, even optic nerve swelling and retinal folds. The culprit? It appears to be the way weightlessness affects blood distribution in the body. In space, blood flow increases to the head and slows down in the eye's venous circulation, leading to expansion of the choroid, the layer that provides blood supply to the retina. The good news is that for missions lasting 6 to 12 months, these changes typically aren't permanent. Most astronauts' eyes return to normal once they're back on Earth, and wearing corrective eyeglasses is usually sufficient to address any symptoms developed during their time in space. However, this raises serious questions about longer missions, particularly potential trips to Mars. Right now, we simply don't know what prolonged exposure to microgravity might do to astronaut vision over extended periods, and we don't yet have any preventive measures in place. As we continue to push the boundaries of space exploration, understanding and addressing these health challenges becomes increasingly crucial for the future of long-duration spaceflight. Okay. I promised you a black hole story today, and I found one. The first ever black hole to be imaged by humanity, known as M87 star, has revealed some fascinating new details about its eating habits, and they're not exactly what you'd call neat and tidy. Recent observations from the Event Horizon Telescope have given us an unprecedented look at the turbulent nature of this cosmic giant's feeding patterns. Located 55 million light-years away at the heart of the Messier 87 galaxy, this supermassive black hole, weighing in at a staggering 6.5 billion times the mass of our sun, continues to surprise astronomers. By comparing observations from 2017 and 2018, scientists have noticed some intriguing changes in the bright ring of superheated gas swirling around the black hole's edge. The most striking discovery was a 30-degree counterclockwise shift in the brightest section of the ring, pointing to significant turbulence in the plasma surrounding M87 star. This movement tells us something remarkable about how the black hole feeds. The matter appears to be flowing inward in the opposite direction to the black hole's rotation, creating a complex and dynamic feeding process. What's particularly exciting about these findings is how they're helping us understand the environment around black holes. The bright ring we see isn't just a static feature. It's a dynamic, ever-changing structure of plasma moving at nearly the speed of light. This matches incredibly well with what Einstein's theory of general relativity predicted, giving us yet another confirmation of this fundamental theory of physics. Using 3 times more data than was available in 2017, scientists have been able to build a much more detailed picture of how M87 star interacts with its surrounding environment. These observations are helping us understand not just how black holes feed, but also how they influence the space around them. As researchers continue to analyze data from 2021 and 2022, we're likely to learn even more about the complex dynamics of these fascinating cosmic objects. Next up, get your telescopes ready. Stargazers are in for a treat this February with a spectacular celestial display featuring some of the brightest objects in our night sky. Venus, our dazzling sister planet, will be putting on quite a show in the southwestern sky just after sunset, reaching its peak brilliance around February 14th, when it will shine at an impressive magnitude of -4.64. The month kicks off with a particularly picturesque arrangement in the early evening sky. A young crescent moon will gracefully pass between Venus and Saturn on February 1st, creating a beautiful cosmic triangle. The following evening, the moon will climb higher to position itself just above Venus, offering another stunning photo opportunity for astronomy enthusiasts. Venus will reach its highest point in our evening sky on February 7th, making it an ideal time for observation. Through a telescope, you might even catch glimpses of the planet's phase changes, as its visible illuminated portion shrinks from about 37% to just under 15% throughout the month, while its apparent size grows larger as it moves closer to Earth. Saturn, though not as bright as Venus, adds its own charm to this celestial dance. The ringed planet will be visible low in the southwestern sky, shining at magnitude 1.1. Telescope users might want to take advantage of this opportunity to observe Saturn's famous rings, which are currently tilted at just 2.8 degrees. This is particularly significant as the rings are approaching their edge-on position, which will occur in late March. Though, unfortunately, this final transition won't be visible from Earth due to Saturn's position relative to the Sun. Happy stargazing. Well, that wraps up another fascinating episode of Astronomy Daily. I'm Anna, and I've enjoyed sharing these amazing space stories with you today. Before we go, I want to make sure you know where to find all the latest space and astronomy news anytime you want it. Head over to astronomydaily.io, where you'll find our constantly updating newsfeed and can catch up on all our previous episodes. We're also very active on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube, YouTube Music, and TikTok. If you're enjoying the show, make sure you're subscribed wherever you get your podcasts. We're on Spotify, Apple Podcasts, YouTube, and pretty much everywhere else you might listen. And remember, the universe is constantly revealing new secrets, so keep looking up and join us again on Monday when Steve and Hallie will be here for another journey through the cosmos on Astronomy Daily. And to our Australian listeners, happy Australia Day.